Okay, so we're starting 2.8 today, which is function operations. So the first operations we're going to look at are adding and subtracting, and then multiplying and dividing. So I'll let you write these rules down. So you have done these operations before with polynomials. So it's really the same thing, you just haven't really seen this notation maybe. This asterisk does mean multiplication. The reason why we put an asterisk there is because if you have a dot, hold on. If you have a dot, then you have to make sure that it's closed. So that's multiplication, but if there's an open circle, that is not multiplication. That's composition, which we'll talk about tomorrow. Okay. And then the only thing when you're dividing, you can't divide by 0, so you just have to make sure that whatever you plug in for x is not going to give you 0 in the denominator. Okay. So let's do this example. So f of x is x squared, g of x is 2 minus x, and first thing I have is f plus g of x. So as we just noted, f plus g of x is the same thing as saying f of x plus g of x. So f of x is x squared. G of x is 2 minus x. So when you're adding functions together, you don't need parentheses. All you're doing is combining like terms. I don't have like terms here, but let's write it in standard form. So go ahead and write it as x squared minus x plus 2. Now it doesn't factor, but if it did, you would not need to factor here. Don't factor. All we're doing is just the adding and subtracting part, multiplying, dividing. We're not having to factor anything. Okay, so same thing then with f minus g of x. So f of x minus g of x. Okay, so that's x squared minus. This time I am going to use parentheses, so I remember to distribute the negative. I'm subtracting that whole function. So 2 minus x. Okay. So distribute your negative. So that's minus 2 plus x. Which gives me x squared plus x minus 2. So I will take the time to put those in standard form just to put them in the correct order, but as far as factoring, I don't have to do that. Okay, multiplication. Fg means f times g of x. So f of x times g of x that's x squared times 2 minus x. So how will I multiply those? Distribute. So 2x squared minus x cubed. So negative x cubed plus 2x squared. Yeah, so you should write it in the correct order. Okay, and then f divided by g of x. That is f of x over g of x. So f of x is x squared. G of x is 2 minus x. Because of that subtraction in the denominator, this 2 minus x has that invisible parentheses around it. When it's in a numerator or denominator, it has that invisible parentheses. So that means I cannot cancel those x's. So this is the most I can do to simplify. Okay, so this is done. But I want to know, in a minute we're going to talk about the domain, but for now, I want to just go ahead and note the disclaimer. So this is the quotient, this is the answer, as long as x does not equal positive 2. Good. What are you doing? Okay. All right, so I want to give you the chance to practice this. So we're doing the same thing. There's a D as well, the F divided by G. So same A, B, C, D as before. So take a minute to do these and then we'll check. So let's check. So F plus G of X, you should have gotten 6x minus 6. F minus G of X, you should have gotten negative 2x minus 4. Then F times G of X, you should have gotten 8x squared minus 22x plus 5. So you have to FOIL that one. Okay. And then F divided by G of X is 2x minus 5 over over x minus 1. And then the disclaimer, so it would be what the denominator can't be. So you would have 4x minus 1 can't equal 0. So that means x cannot equal positive 1/4. So any questions about these four? Okay, so we're going to do a couple examples of these quotients of the division and go into detail about the domain. So first of all, I want to find the quotient. I want to find f divided by g of x. So that means I'm going to do f of x over g of x. So f of x is x plus 3, and g of x is the square root of x plus 1. So here's the quotient. And then I'm going to talk about the domain, which is the disclaimer part. So if I talk about the domain, let me rewrite our quotient. So I'm wanting to find the domain of x plus 3 over the square root of x plus 1. Okay, so it's a rational function, meaning there's a denominator. So first of all, I know that I can't divide by 0, so I know that the square root of x plus 1 cannot equal 0. If you square both sides, say then 0 squared is 0. So really you could just say x plus 1 can't equal 0. But I have a second part to that because I also have a radical. So if you have a denominator and a radical, then that's two parts. So the radical tells me that whatever's underneath the radical, so x plus 1, must be positive. So must be greater than or equal to 0. So two parts to this domain because you have a radical and a denominator. But since they are the same in the same place, you have the radical and the denominator, then we're able to put these together and just say that x plus 1 is greater than 0. So you take off the equal to part since it can't equal 0. So that means x must be greater than negative 1. And that is what I will use to write my domain. So greater than negative 1 means parentheses at negative 1 since it's not equal to, and then it goes to positive infinity. That's the domain. My x plus 3 on top doesn't matter. You could have a 0 on top. You could have a negative because there's not a radical. That doesn't matter. What mattered was this denominator, and it was also a radical. Any questions about that? Okay, let's do another one.
Ms. Cecil, could you send McKenna Nichols to check out his attendance?
Yes.
Thank you.
Okay, so notice that this is g divided by f of x. So this is going to be, the g is on top this time. So g of x over f of x. So square root of x plus 5 over x plus 2. So here's the quotient part. Now we'll talk about the domain. Okay. This one also has two parts. It has a denominator and a radical. So the denominator part here, I know, okay, x plus 2 can't equal 0. That's what being in the denominator means. But then I also have a radical. So this time my numerator matters because it's a radical, because it's a square root. So that tells me then that x plus 5 must be greater than or equal to 0. So radicals tell you greater than or equal to 0. Denominators tell you can't equal 0. Now the one I just did, I was able to put together, because they were the same part. They were the radical and the denominator. So I was able to put them together. These are not the same part. Like you can't just say x plus 5 must be greater than 0. That doesn't have any effect on my negative 2. So I have separate parts here. Does that make sense? You guys see the difference between the two? Okay. So the denominator then tells me that x can't equal negative 2. So that's part of the domain. Then I also have that x must be greater than or equal to negative 5. So those are the disclaimers. Now I got to write it as a domain. So when I write it as a domain, I need to include both parts. So I think it's helpful to use a number line so we can see it. So I'm going to graph both of these on a number line. So if I do this first, x can't equal negative 2. So that means there's a hole there at negative 2. Okay? Then I also have that x must be greater than or equal to negative 5. So greater than negative 5 means I would shade to the right. I have to skip that hole though, because that hole is still there and I'm combining these two. Since it's equal to, that means there's a bracket there at negative 5. So when I write my intervals for my domain, I write the parts that are shaded. So this hole breaks this into two parts that are shaded. So I'm going to have two intervals. So x is an element. The first one is from negative 5 to negative 2. Since that's a hole, I have to use parentheses. Okay, then the second shaded part starts back at negative 2 with parentheses. So remember to show the holes, you have the double parentheses. And then it goes to positive infinity. So the number line isn't mandatory for your answer, but I think it really helps you to write it. Like even when I did this the first time, I had to think about it, and the number line is what made it easier for me. So don't be afraid to do that if you need to see what it looks like. Your domain is the parts that are shaded. You want the possible values of x. Okay? Questions about that? All right. So we're going to do one more example, and then we'll stop there. So we're going to do one more example. We're going to do this, and then I'm going to show you kind of two ways to do it. So I want to find f minus g of 0. So first of all, let's find f minus g of x, okay, and get that new function, and then we can plug 0 into that. So if I find f minus g of x, I'm doing f of x minus g of x. So that's x squared plus 1 minus x minus 4. I have the x minus 4 in parentheses, so I distribute the negative. Okay, well, let's distribute the negative. So minus x plus 4. I have some like terms to combine. And then I'm going to write x squared minus x plus 5. Okay, so that's f minus g of x. So let's do f minus g of 0. Well, plug 0 in for x. What do I get? 5. Okay. That's it. That's your answer. So I had this option of subtracting the functions first and then evaluating and then plugging in 0. Or I can evaluate first and then subtract. So, or I can do f of 0 and then g of 0 and subtract those two numbers. So if I do f of 0, so right now f of 0 means I'm just plugging in 0 to my f of x function. So 0 squared plus 1 is 1. Okay, g of 0, I'm just plugging in 0 to my g of x. That's negative 4. Okay, then f minus g of 0 is 1 minus negative 4 which is 5. So you aren't required to do both ways. You could choose. Sometimes, like when we get to graphing or doing this from a graph, it's going to be easier to do this second way. So you could subtract them first and then evaluate, or you could evaluate and then subtract. Questions about that? Okay, that is where we're going to stop. So we will finish this up tomorrow.